Hi, this is Mr. Blay. We're here working on a word problem today. This is really designed to help you with your IXL U9 section. We're doing systems of equations, and this is a word problem that we're going to have to turn into two equations and then solve. So as you can see here, the problem says the Woodward family is looking to rent a large truck for their upcoming move. With Charlie's moving, they would pay $96 for the first day plus $4 for an additional day. With Oakdale Rent-A-Truck, the family would pay $61 for the first day and $9 per additional day. Before deciding on the company, Mrs. Woodward wants to find out what number of additional days would make the two choices equivalent with regards to cost. What would the total cost be, and how many additional days would that be? So the first thing about this is that since we're doing a system of equations, we need to come up with two equations. So the main thing we need to look for is a changing value here. And we also need a fixed value. All right, so the main thing with the changing and fixed value is the fact that the fixed value is right here, is the $96 for the first day. The 4 for the additional days, that would be the changing value. So the 4 additional days, this over here is actually the fixed, right there. All right, so if you're gonna write an equation that has to do with a changing value and a fixed value, changing always represents our slope, and fixed values are always represented as our y-intercept or our b. Okay, so for Charlie's Moving Company, all right, our equation is y equals 4x plus 96. Okay. For the next moving company, which is the Oakdale, that equation is going to be very similar. You still have a fixed value, okay, which is going to be the 61 as your fixed value. You have the $9 as your changing value. So your slope is the 9x because that changes every day, and then you add the 61 for the first day. Now, in order to solve this problem, what you have to do is you have to take one equation and plug it into the other. So since Oakdale, since this says y equals this value, you can take this value here and plug it in for the other y value. Okay, so once you do this, here's essentially what you would have. You would have your 9x plus 61. You'd have your 4x plus 96. And then if you move your x's to the same side by subtracting 4x, you'll get 5x plus 61 equals 96. And then if you subtract 61 to the other side, you'll get your 5x equals 35. And when you divide both sides by 5, that will give you your x as 7. The only thing you need to do at this point is figure out what the x actually means, because you'll notice in the problem it says how much money we're gonna pay versus how many additional days we're gonna work. So if you notice here, the 9 and the 4 x's, if you go back to the problem and look at the 4 and the 9, it'll kind of tell you what you're working with for an x value. So here it says $4 per additional day. Okay, and over here it says $9 per additional day. So that x represents additional days. Okay, so this is additional days. All right, which means our 7 is going to go here in our answer. Okay. Then, in order to find the money that they'd have to pay either way, you got to take your 7 and you plug it back in to either one of these equations. It doesn't matter actually which one you really work with. Okay. So if you plug it into this bottom equation, you'll get y equals 9 times 7 plus 61. which gives you 63 plus 61, which gives you a total cost of 124. All right. Now, if for any reason you question, okay, if for any reason you question whether or not this 124 is right, or you question whether the 7 is right, if you plug that 7 into your other equation, you should get the exact same 124. If you don't, more than likely your x value is wrong. Okay? But if you do, then your x value should be correct. So if you plug in the 7 to that top equation, just to show you real quick, you'd have 4 times 7 plus 96, and then that gives you 28 plus 96, which also equals 124. All right, so right there is just proof that no matter which equation you put the 7 into, you still get the same number. All right, so that's just a problem here, or a word problem for systems of equations. Hope this helps.